All right, so this morning we're learning about RESTful API design. I know that previously in this cohort, I've kind of glossed over this, saying that, we're going to cover this later. And up until now, we haven't been really too concerned about how we wrote our URLs for our APIs. Just sort of cowboy coded anything we could do to get the data going up to the server and get a response back. That was good enough. But today, I'd like to talk about kind of the customs and conventions about how developers typically choose to write their URLs and how they choose HTTP methods in a way that you can write your URLs in the same style as other developers, so you can know what to expect from each other, so that if you're using an API that is unfamiliar to you, you'll still have some kind of understanding of how it all works. So it's just about being part of the community, getting on the same page as other developers. So first, let me just define this term here, REST. This is an acronym. It doesn't really matter if you know what it stands for, but I feel like I should write it out anyway. So it stands for representational state transfer. The E is not actually a word by itself. It's just the E in representational. So it's kind of a weird acronym. But so generally, I'd say this is a very poorly understood concept. That means different things to different people. So many newer developers understand REST as a system for mapping CRUD operations like create, read, update, delete. So mapping these CRUD operations onto HTTP methods like post, get, put, and delete. So this is kind of a naive understanding of REST. I feel like most people, when they exit a programming bootcamp, or if they just read their first tutorial on REST, this is basically how they understand it. So I would say that this is wrong, but it's a pretty useful way to understand REST if you just want to build an application that uses an API. So if this is all you know about REST, like you can go places with that. But technically, this isn't quite right. So other more experienced developers might tell you that you can't fully understand REST unless you read Roy T. Fielding's doctoral dissertation published in the year 2000. So this is correct, but it's not incredibly useful advice more than 20 years later. The internet as we use it today is very different from how it was in the year 2000 and very different from how Roy Fielding imagined it would be. For example, consider this gem of wisdom from his thesis. So I think this is kind of hilarious. It's hard to have known in the year 2000, but in hindsight, this quote seems a little bit silly because we know today that cookies are a common and essential part of the modern web. So, it is an interesting historical document to read through, but I don't think that reading through that dissertation is going to really help you understand what is expected of you from other developers in a modern professional context. So I'd say I'm going to define what REST actually is then. So in modern practice, it's a software architectural style for creating scalable web services that make resources available to clients. So for the rest of this lecture, I'm going to tell you about a bunch of different features of RESTful APIs and things that they ought to do. But the important thing to remember is that you don't need to implement every aspect of this style in your own API for it to be considered a RESTful API. I would say that the more of these aspects that you implement, the more restful it is. And so you should try to find a balance between conforming to well-known standards and building an API that fits the specific quirks of your application. All right, so this isn't like an all or nothing kind of thing. We're trying to take kind of a balanced, nuanced approach, striking a balance between, something that's reasonable for our specific application and building something that is intelligible to other developers. Figure especially, like this is definitely very useful for a public API so that, people who aren't part of your organization, who've never met you before, can understand your API without like reading every line of documentation. But it's also very useful, just in an internal application for a company to build your API conforming with this style, because then as other developers are onboarded to your application, they'll be able to onboard very quickly and learn how things work easily. Whereas if you have a completely custom scheme for your API, when you hire new developers, it's going to be really hard for them to figure out how to work with the API. Especially a lot of dev shops are just like revolving doors of developers, people coming and going every like 6 to 18 months. So it can definitely be helpful if your API is conventional and very intelligible to other developers. So I also want to clarify here, REST is not a specific technology, tool, or library, or even a standardized protocol. So really, like REST, I feel like is like art in that it's impossible to look at an API and say that this is or is not REST. It's always a little bit subjective. Some things are definitely very RESTful. Some APIs are clearly not very RESTful, but there's always a lot of gray area in between. And note that there are some tools and libraries that help you to create RESTful APIs. So, I've briefly mentioned Django REST Framework, which includes a bunch of functions that help you make an API very quickly that conforms to these conventions I'm going to tell you in a minute. But REST itself is really just an architectural style. It's a way of building APIs, not necessarily attached to any specific tool. Alicia, do you have a question?
Yeah, so this is probably like an extremely newbie question, but I just want to get clarification. Like the API itself, is that the list of URLs for get, post, delete, etc.? Like, is that those list of paths and stuff? Is that considered the API?
Yes. In this context, that's exactly what I'm talking about. So yeah, it's just the interface between your front end and your back end. It's the list of URLs you can send requests to and the type of requests you can send there and what you get back from those requests. It's like a contract between the front end and the back end. So the most basic concept in REST is called a resource. But this is actually a little bit abstract. So we say that any information that can be named can be a resource. So for example, a document or an image possibly a temporal service, such as today's weather in Los Angeles. A resource could be a collection. For example, users could be considered a resource. An individual user could also be considered a resource, but users as a whole, you can consider that like a collection resource. Resources can be queried or modified using HTTP verbs. And REST APIs usually, not always, but usually represent resources as JSON data. So I actually feel a little bit weird including this last one here, because like technically, like REST has nothing to do with JSON. Technically speaking, a REST API can return any format of data. But it's very common nowadays that REST APIs return JSON data. So I think if someone is asking you, like, what are features of a REST API, it's a reasonable thing to say that they generally return JSON data. It's not like a defining characteristic, but this is generally true. So yeah, other examples of resources would be like basically anything that we create a model for would be a resource, I guess. So you could have like a Pokemon resource, like an events resource if you're making like a calendar application. Yeah, basically anything you would store in a database table, you could, in a RESTful context, you would call that thing a resource. All right, so the next really important concept for a RESTful API is statelessness. So what this means essentially is that the server does not keep track of the clients from one request to the next.
It seems like it would be a bit of it almost seems like it would be extra effort to make an API stateful in the first place. So is it the act of avoiding making it stateful? I mean,
I'm sorry, can
statelessness
you
seems
repeat
to be
that?
kind of, it seems like it would be extra effort to make an API kind of stateful in that sense. So when you're mentioning the statelessness, it seems more like just avoiding implementing a stateful API. I don't quite recognize or understand how an API outlet, I guess you can say, would be anything other than stateless.
So consider the APIs that we build between our front end and our back end. So that's not a public API, that's kind of the internal API for our application. That API is stateful because we use cookies in our application that identifies the user. So after you sign up and you log in, you can send a request to the server that is an incomplete request. You're not telling the server which user is sending the request. You're just giving them a session ID, and then the server connects that to your user ID, and then it can figure out what the user is and other information about the user and your permissions and whatnot. So in a sense, then using cookies like that is not really RESTful, but it's very convenient, so we do it anyway. Whereas with a public API, you don't like have a session with the public API. You have to authenticate every single request you make if it requires authentication. So in that case, with a public API, that example is more RESTful in that it requires you to identify yourself and authenticate with every request because it's not keeping track of you from one request to the next. Does that kind of make sense?
Yeah, that does make sense. Thanks.
Mhm. So just kind of like what I was saying before, we don't need to follow every single principle of RESTful design in all situations. You know, some of these principles make more sense for a public API where we're trying to, you know, like the Pokemon API, where we're trying to serve as many visitors as possible using as few resources as possible because it's a free API. You know, they don't want users costing them a bunch of money with all the requests they're sending. So part of that is by being stateless, by not keeping track of the users, they're able to serve a much larger number of users because they're no longer limited by how many users they can keep track of at once, since every user is supplying all the information needed in every request. So this is maybe one of the more fundamental concepts of REST, but this is about all I have to say about it. Does anyone have any questions before we move on?
And just as a side note, statelessness also helps architectures scale because you don't have to like keep stuff in memory, and a server can handle more requests.
Yep.
Sorry, I'm just trying to understand exactly what you mean by that, because like we asked for the cookie, but if we weren't asking for that, I mean, how would that work?
Like how would the application work if we didn't have cookies?
Yeah.
You would have to send your username and password with every request,
Oh, okay.
which is effectively how public APIs work. You know, like with the Noun project API, effectively what that's doing in your backend is you're sending your username and password with every request you make to that API.
But we're doing that via the secret key and
Right.
whatever they give us. Okay.
All right. Skylar?
Wouldn't that kind of lead into something kind of like you could have people register on your website and then like, let's say they have the username and password, could you have an API call that does require their info to make that request? So you have your API set up that requires the usernames authentication, like username password to make the request. Are those even done, or is
With
that
every request?
I don't know, maybe, I guess, or like, I don't know, maybe I'm just being crazy. I'm just trying to think of something like, I think I've seen some stuff about that, like where you can take an account and pass the info through. But I'm not sure.
Yeah, I'm not sure how that would work. I'm imagining a website that has like a login form next to every form. so that you can always like prove that you're an authenticated user with every request you send.
I am not a robot.
I think I'm a little crazy. All right, thanks.
All right. So moving forward, a really important thing in REST is choosing the right HTTP methods or the right HTTP verbs. And we use different verbs to perform different actions. So like I was saying before, oftentimes these actions map to one of the 4 basic CRUD operations. I showed that up here. This is commonly true, but this isn't like, they're not exactly the same thing. REST and CRUD are not the same thing. There is one really important aspect of these HTTP verbs that we need to consider in order to choose the right one for different circumstances. And I'm going to drop a word bomb on you here, but please pay attention.
It's not the F one, is it? Oh, okay.
The I one. Idempotence. The most important aspect of an HTTP verb when deciding which one to use is idempotence. We say that in computing, an action is idempotent if performing it once has the same effect as performing it multiple times.
I Googled idempotency. And I got this website and it has a video, the 4-minute YouTube video. And the thumbnail for it says, let's say you have a cow. ... I'm curious where that's going. To explain idempotency. Let's say you have a cow.
Yeah, I can't imagine. And then another quick definition here. So this is an idempotent HTTP method. Performs the same action sent once versus multiple times. Similarly, a safe HTTP method has the same effect if performed multiple times as if it were not done at all. So we'll talk first about a safe HTTP method. So that would be GET is probably the simplest example of that. If you send a GET request to a URL, it is assumed that that has no impact on the server state. So it's not going to change anything in the database, or, I mean, yeah, it's not going to change anything in the database, basically, is the primary assumption. So as a client, as a user, I can send GET requests to a server all day long, and I don't have to worry that it's going to like mess anything up on their end. So in contrast, let's say like a delete request is considered to be idempotent. Actually, let me write this down. So I also mentioned delete. Delete is idempotent. A delete request should have an effect on the server the first time you send it, but after that, it shouldn't have any additional impact. So imagine if you sent a delete request to /API/users/345, like this is a user ID. The first time you send this request, it deletes this user. But the second time you send this request, this user already doesn't exist. So trying multiple times to delete the same user is not going to have any additional impact. Similarly, put is also defined as being idempotent. So if we try to send a put request to /API/users/345, and we have a body with username Steve. So the first time we send this request, it's going to find user 345, and it's going to change their username to Steve. But if we send that request a second time, third time, 20 times, it's just going to basically reiterate the fact that their username is Steve. It's just resetting it to what it already was. So sending this put request multiple times is not having any additional impact on the server. Now, the big exception here is post. Post is not idempotent. So you should expect that every single time you send a post request, it is going to have an impact on the server. So if we imagine a request like post to /API/users, username Steve. So a request like this, according to RESTful conventions, you would expect this to create a new user named Steve. And in this case, we're not specifying the user's ID. So the server, the database, would have to generate an ID for them automatically. So if we sent this request twice, it would just generate another user with the username Steve, because these usernames, I'm assuming, are not unique in our system. And so if there was some glitch and we accidentally sent this post request 10 times, we would end up with 10 users named Steve in our system. So I hope this kind of illustrates to you why idempotence is important. And in part, it's because computer networks can be unreliable. Sometimes data just gets lost over the internet. It just doesn't make it to its intended recipient. And sometimes we have to resend the data. So a lot of times this happens automatically. This kind of error correction is built into the web protocols we use. We don't usually have to think about it. But sometimes we do think about it. Sometimes our code fails. And so we can actually write our code to automatically retry a request. And so we know, based on RESTful conventions, that if we fail to send a put, delete, or a get request, then it's totally safe to just try resending it. Or maybe if we're not sure if it was sent successfully, so maybe we send the request successfully, but the server fails to respond. So it actually does get the request and we just don't know it. Well, in that case, we can still just keep resending that put request. And if we send duplicate requests, there's no harm, and we can just keep sending until we get a response. But if we're sending a post request and we're not sure if the recipient got it, you have to be a lot more careful with that. You have to make sure that you double check to see if they actually got the response. You need to get some kind of confirmation, or get some confirmation that they didn't receive the request somehow before you resend the post request. So it's like maybe you've been on a page with a form and then you submit it, and then you'll get this warning message saying you not to refresh the page because that'll resubmit the form. And that's because if that form is submitted with post, your browser assumes that it's not safe to just automatically resend that same request a second time, that it's going to have duplicate effects. So it'll warn you about resubmitting that form that was generated with that would submit a post request. So throughout this lecture, I'm going to talk about a bunch of other important aspects of RESTful API design. But in my opinion, this is the most important one. Just remembering the idempotence of an HTTP verb, knowing when to use which one. If you remember just one word from this whole lecture, please let this be it, idempotence.
So, Raf, it's it seemed like you, I mean, idempotence, great. We talked about the 4, get, put, post, delete, and it seems like the takeaway is just kind of recognizing the idempotency of each one, and the fact that post is not idempotent.
Correct.
Is there something is it just recognizing that is how they function, or is there something we can or should be doing to prevent or to make it different?
So like in my mind, the thought process is if you need to perform some action on your server, you're going to have to write a route. You need to ask yourself, is this action idempotent? If I perform this action multiple times, is it going to have a different impact on the server every time I perform this action? If the answer is yes, you should be using post for that request, because of these common method types, post is the only one that is not idempotent. Post is the only method type that communicates to clients that this is potentially dangerous, that every time you send this request is going to have an impact. So make sure you're not like doing this in a loop that gets out of control. Make sure you're not resending these automatically. And if you're trying to perform an action that is idempotent, do not use post. You should use, delete if you're removing something, or use put if you're modifying something.
I see. So we've already kind of been accidentally implementing this without kind of realizing the importance of separating them out. I see.
I suspect some of us might have gotten put and post mixed up.
Okay. Because technically you can post all 3 of those and behave them. I see.
So imagine an API for like a bank. So if you had a URL, it's like API/users, API accounts, account number 987. We'll say slash. So if you have a URL that is just like adding money into your account, so this would be a post request, because in theory, every time you call this, it adds $200 into your account. Whereas if we just kind of phrase this a little bit differently, so I'm gonna say this isn't specifically an account. This isn't specifically a deposit. I'm just modifying the account, and I'm just gonna set current balance equals bunch of money. So for this one, I would prefer to use a put request, because here I'm setting the balance to a specific value. So if I accidentally sent this request multiple times, it wouldn't have any additional effect. It's just continually setting my balance to that same number it was already set to. So
can you treat a couldn't you, I'm kind of spitballing here, couldn't you make post idempotent by receiving the request, performing an internal GET request, and then turning it into a put request? Or a put statement, you know what I mean?
I
Like
mean,
you
what do
just
you mean
did.
by,
So for example, if they said, hey, I want to post $200 to my account, you'd receive that request, fetch their account balance, add 200 to it, and then do a put request to it. I guess that wouldn't make a difference because they could still say, I guess that really doesn't do anything. All right, never mind. Don't mind me. I'm just going to sit here and be quiet for a little bit.
so yeah, it's important to remember that these different method types are not actually mechanically different from each other. So, I mean, one exception to that is that GET requests do not have a body. But other than that little difference, that little detail, delete, post, and put are exactly the same as each other, just as a matter of technology. Like Axios, like the tools that we use for sending these requests, Axios is not going to make any not going to make any differences between put and post. The only difference between put and post is what people interpret them to mean. So, like if you have a route on your server that accepts post requests, but a user sends like 3 duplicate requests there and it only has one effect, that's kind of defying their expectations because users would expect a post request to have an impact every time you send that request. And so what would probably be worse is if you have a URL that uses put requests and a user sends 3 duplicate requests there because they weren't sure if you received it in the first place. But each of those put requests has an impact on your database. That would be really bad because that would be defying the user's expectations, because the user should expect that if they send 3 duplicate put requests, only the first one has an impact, and then the second 2 kind of do nothing. So yeah, in the back end, we can make any of these requests do almost anything we want them to do. But the important part is conforming to your users' expectations so that they know when it's safe to like automatically resend requests. Skylar is asking what happens if a bug happens and it doubles the post. That's bad. That's worse than a bug that doubles a put request. So you need to be extra careful with it. But like a lot of the tools that we use, like, I mean, like the browser itself, you know, is gonna warn the user about submitting duplicate post requests. So there is like, I think some understanding built into the tools we use. They're like less likely to automatically retry post requests. But yeah, you got to be careful. So actually, let me pose another thought experiment to y'all's. Actually, hold on. So before I go there, I want to give another put example here. Well, don't forget about that. Okay, so quick thought experiment for y'all's. For the logout route, what method type do you think would be appropriate for logout?
Post or
Post.
put?
It's almost like a delete. But
It is
that's
kind of.
I mean,
Just
can't you
like-
only log out once? So would it matter if it's idempotent or not? Idempotent, however you say it.
So if you can only log out once, then I would say that that request is idempotent. The first time you send the request, it logs you out. If you continue to send logout requests, it's not going to do anything else because you don't have an active session. So in my mind, put would be the most appropriate method type for a logout request. I think in the code snippets we've shown you, we just used post. And I think in general, post is a little bit more common because honestly, logging out is not necessarily like part of your RESTful API. Like you can have RESTful and non-RESTful parts of your API, like log in, log out, sign up, sign out. Doesn't necessarily need to conform to those conventions because you might have specific needs for those routes. But the important part is just not using get for the logout, because a get request is defined as never having any impact on the server state, whereas logging out, that does have an immediate impact on the server state. It ends your session. So the reason why I'm bringing up this example in particular is because I was actually reading on Stack Overflow, because I was wondering like if other people use get or post requests for logout most commonly. And apparently a lot of websites used to use get requests for post, but they stopped at some point because Google Chrome added this feature where it would prefetch web pages. So the idea is that like you're on some web page, and Google Chrome wants to pretend like it's the fastest browser available. And so what it's going to do is while you're reading that web page, it's going to look at all the links on that page and send requests to all of the like get URLs to download those pages in advance, so that when you actually click on a link, that page is already loaded and it doesn't have to request it on demand. You can just go right to it. So that's prefetching pages in Google. But the problem is that if one of those links on the page was a logout link, and it's like just a regular get request, anchor tag link, then as Google is prefetching it, it doesn't know that that's not a regular page and that's your logout link. It's going to prefetch that logout, send a request there. And so you just get randomly logged out from the application you're in while you're browsing without clicking on anything. And so some people might think that that's kind of like overly aggressive on Google's part to just be like sending random requests to links on the page. But like if you define this route with a get request, you've essentially promised every user of your website that they can freely send requests to this URL and it's not going to impact anything. So Google is basically just trusting you to do what you said you're going to do, that all of these get routes don't impact the server. And so it's just freely sending requests for its own purposes. And so if sending a get request messes up your application, like that's on you as the application developer.
So when we make a view and we use the Django RESTful framework or Django REST framework, and above our view, we have that at API view. And then in parentheses and brackets, we put post whatever. I mean, at the end of the day, are those simply just labels that help the browser recognize what we intend to do, but they don't actually include any functionality inherent with that label? It's just what we do in the view that's supposed to represent the label.
Right.
You know what I mean?
Right. There's no inherent functionality
Okay.
attached to put versus post. It's just people assume them to mean different things. So, if you're a front-end developer on a project and I'm the back-end developer on that project, and you say, hey, I need some data, and I tell you, oh, it's at this URL over here. We don't have to have an extended conversation about how that URL, how that route works, but you can know just from reading the URL and looking at what method type it uses, you can have certain expectations about what that's going to do on the back end.
How do you know by reading the URL? Well, I guess it would be in your API documentation that explains the method type involved in that URL. Other than that, the user doesn't know what method type is involved with the URL unless they go into maybe their inspection tool. Like if I do a view that does a put request, right? Or like an actual update to information, but I call it API view delete in the decorator. How does that
sorry, say
just confuse? So if I make a view that's supposed to act like a put, but I put in the API decorator above that view delete instead of put, what gets confused? The browser, because it's expecting a delete action from that view? You know what I mean?
Hang on a second. Yeah.
Is that too deep of a question? I'm sorry.
No.
I want to know the relationship.
So if you send a delete request to a URL, but you've used Django REST framework to indicate that it's only for put requests, or I think you said the opposite thing, but still, in that case, Django will automatically send a response with a 405 error code saying that this is a URL that exists. So it's not a 404, but you just
Okay.
sent the wrong method type to this URL and we can't process this.
Hmm.
So that's one of the features of Django REST framework is automatically sending this response for inappropriate requests.
Okay. I mean, when we make our views, like if I make that API view delete, and then inside that view, I say, I have the view actually perform the delete on the database. Who's to say I don't write that view to update the database instead? So now that delete view is actually performing an update, and it's just messed up. You know what I mean? That's the developer's problem. The computer or the browser doesn't know any differently, right?
Right. The browser doesn't know any different.
Okay.
It's just that if you're trying to collaborate with a front-end developer, they might be kind of surprised and frustrated that your
Sure,
API
okay.
doesn't behave the way
Do what
they
it
kind
says.
of assumed it does. Yeah.
Okay. All right. Thanks. That was probably weird for a lot of people. I apologize, but it helped me kind of clear up a weird little confusion in my head. Appreciate it.
I mean, REST is kind of a weird topic because, most of the stuff that we learn in this course is very mechanical. It's about, what these functions do, how they act, how the data moves around, what the laws and rules, these different protocols and standards are and whatnot. But this is a lot fuzzier than a lot of the things that we've learned so far. A lot more subjective, I think. So it's understandable if people have unusual questions. Alicia?
So just want to make sure I understand too. So like an example of adding a friend on like a friend list, that would be better to be a put request because when you add them one time, they become your friend. But then if you send the same one, you don't want it to keep adding the same friend to your list. You just want it to do it the one time.
Yeah, I'd say so.
Okay.
Yeah, because that would be adding a record to a join table for two users to say that they're friends with each other. But that record itself would be unique, so you couldn't add the same friendship twice. And just conceptually it doesn't make sense also. But yeah, that's totally correct. Do we have other questions that we want to talk about?
One more thing. So when you did the full stack app and you did the views for login, logout, and sign up, your decorators for all three of those were API view post, which is not wrong, but technically sign up would be post, and then login and logout would be more of a put. And then we'd do axios.put for those because they are idempotent behaviors, right?
I mean, you could even consider the sign up to be a put because the emails have to be unique. So there's
True. Yeah.
no way that so I mean, this was kind of a contrived example
I see.
because I'm just using one property that's not unique. But like for the sign up, yeah, email should be unique. So two duplicate sign up requests shouldn't give you two users in the database. But also like the sign up, login, logout routes, like you don't have to think of those as part of the RESTful part of your API. Those can kind of just exist on their own with their own scheme, just whatever makes sense to you.
Okay.
Because yeah, you probably wouldn't even use the URL /signup if it was part of a RESTful API.
That makes sense.
It
Yeah.
would be like post to users or like put /users.
Okay.
So this REST framework stuff we would mostly be wanting to do for like returning JSON data, not so much anything else. Or could you find yourself using this for other things?
Both are correct. You would mostly use it for returning JSON data. I have seen instances where like, a RESTful API would return HTML. I think that was actually Roy Fielding's original conception, original like vision of REST. was not actually about like JSON-based HTTP APIs, but about like getting HTML with links to other HTML pages. So like in a lot of ways, like the regular web is more of a REST API than like, according to Roy Fielding, than like the REST APIs we use today. That's kind of an aside though. Does that answer your question? Sorry. Kind of maybe. All right, let's
Raphael, so at the end of line 35, did you mean to put a request, or is respect what you meant to put there?
Yes, I did. In a public REST API, the client must authenticate every request. Yeah, sorry about that. All right, so before we move on to the next section, I just want to show you one thing real quick. So you might think I'm like weird for dwelling so much on idempotence of these verbs and trying to convince you that it's the most important thing about them. But like, I really do think this is important. I didn't like come up with this idea, but these are actually the terms in which these HTTP methods are defined originally. So what I'm showing you right here, this is an RFC document, stands for request for comments. These are like the most authoritative documents that define the standards of the web. So, you know, HTTP isn't really like officially defined, but there are, you know, some agreement, I guess I would say, on how things are supposed to work. And the most authoritative descriptions you will find about web standards are in these RFC documents, request for comments. And the reason why it's called RFC is because imagine these were used in order to define the internet in the first place. So they didn't have the benefit of the internet while writing these. So people would literally print them out on paper and then walk them over across the hall to their collaborator's office and lay them on their desk and be like, hey, I'm designing this thing called the internet. What do you think? Can you just like write some comments in the margin here? And so like this document would literally be printed out and people would just write on the right side here, like REST is dumb, we would never do this, or whatever they thought. Today, you know, I don't think people comment directly on them anymore. There's certainly discussion that happens somewhere, but the name is still stuck, request for comments. So this one, RFC 2616, this is the one that defines HTTP. We can see some pretty big names on here, like R Fielding and Mr. Xerox. I'm assuming he's related. Or, oh no, that's the company he's from. Never mind. But okay, it's a real company. And Tim Berners-Lee, who's, you know, the inventor of HTML or whatever. So some serious names here. And then if you look down in the table of contents, there's section 9 for method definitions. The next sections in the table of contents are safe methods and idempotent methods. Before it actually tells you anything specific about the methods themselves, it's breaking them up into these two categories. They're safe or idempotent, or things that are neither. So really, like if you go back to the original definition of these methods, this is the most basic way that they are defined.
So Raphael, you mentioned that you know, our login and stuff is not exactly RESTful because it you know is sending it to /login. So in the URL, I'm seeing in the notes like we're you know, separating out verb and noun. But is that verb, the post, etc., is that actually part of the URL then? Does that come first?
I'm sorry, how do you mean?
So like on line 59, right? Is post actually part of the URL?
No, it's not part of the URL. I'm just saying we would send a post request to this URL.
So then what did you mean by, because you said you probably wouldn't send it to /login. If it were RESTful, you'd send it to like post user or something like that.
So
What did you-
for /login, I'm not really sure what a RESTful route would be, because that's not really about modifying a resource exactly. But for like sign up, I would say that that would be post/users. And we'll talk more in a later section today about how to choose the URLs. But the URL generally should be named for the resource that you're modifying, not
Okay,
the thing that you're doing.
gotcha.
We say nouns, not verbs in the URL. We'll get to that in a second. For right now, I want to talk about responses. So an API is considered RESTful when it uses meaningful HTTP response status code. So I believe I've shown you this before, but we'll just take a look at them again. There's a whole bunch of different status codes that you can return in an HTTP response. And every 100 status codes has kind of a different general meaning. So between 100 to 199, that's just informational, not success or response or success or failure. I don't really use these very often. 200 to 299, these are different types of success. 200 is like a generic success. 201 is also something that's useful in APIs. If the user like sends a post request asking you to create a resource and you do so successfully, it would be more semantic to use a 201 response instead of a 200. Sometimes you'll see 204 if the user asks the server to do something and the server does it successfully, but it doesn't have anything to give to the user. Like the user isn't asking to retrieve any data. The user is just asking the server to do something. You can say like, yeah, I did what you asked me to do successfully, and I have nothing to give you because that's exactly what you were expecting to get back. You could send a 204 response. Alicia, do you have a question?
Yeah, so far when we've done like our get post, whatever, like we haven't been in control of what response comes back. Like it just almost mystically just appears in our browser. So like, is that something that when creating your application, you set up somewhere?
So I believe I showed you at least once how to set status codes. It's on the response object in Django. So yeah, when we create an HTTP response, optionally, you can pass in a status parameter and then just set it to whatever number you want. However, Django, as a very productive backend framework, has lots of default settings for setting these status codes. So generally speaking, if Django is able to return a response to the client, it'll send a 200 status code because that's just generic success. If the client requests something that doesn't exist in your Django server, Django will send a 404 response. I'm sure, so yeah, 404 is not found. I think many of us have seen 403. If you're sending a request that you don't have proper permissions for, Django can automatically send a 403 forbidden response. And I just mentioned before, Django REST framework will send 405 responses sometimes. If you use a post request for a URL that can only accept put, for example. So let's see, I was saying the 300 level, so 300 to 399, these are different types of redirection. There's an important distinction between permanent redirect and temporary redirect. This difference for SEO purposes, I believe. I'm not an expert on that, but like if you have a website that has existed for like 10 years at a certain URL and you've got good brand recognition, good SEO, doing the wrong type of redirect can mess up your SEO. So it's important to know what you're doing there. 304 not modified. This one comes up a lot, but again, this is something that your server sends automatically, so I don't really think about this. But it's if you're requesting something from the server that the browser has cached, then the server will send a 304 response saying that you already have the thing that you're asking for. You don't need me to send you a new version. Just use what you've got locally. So that's not one that you'll have to use, but one that you'll see commonly enough. And then, of course, 500 is generic server error. There's a bunch of other 500 error codes, but like generally speaking, if something goes wrong on the server, you should be able to handle that in like a try catch or like if else or whatever, and then handle it intelligently so that there is not an error on the server. Like generally speaking, the only reason why your server is going to throw an error is because it was completely unexpected, unhandled. And so in that case, your server is just going to throw a generic 500 error. So I guess I've seen 502 a little bit recently. So like Nginx will throw a 502 error if Nginx is set up correctly, but Django isn't. So it's like Nginx can listen to the request and it's able to hand it off, but then there's no one else to pick up the request when Nginx hands it off. You get a 502 in this case. I feel like I've seen 504 occasionally, but these are not things that I would set manually. So I guess for a RESTful API, to the extent that you need to think about status codes, you should think about using the right 200 level status code, like use created as appropriate, no content as appropriate. And then probably more important, honestly, is for the 400 error codes. If your client sends a bad request and you're not able to do what they asked you to do, you should send them a meaningful error code that helps them understand what they messed up so that they can send a better request next time. There's a difference between unauthorized, meaning that you're just not logged in at all, and forbidden, meaning that you are logged in, but you're not allowed to do the thing you're trying to do. There's a difference between 404, meaning the URL doesn't exist, and 405, meaning the URL does exist, but it doesn't accept the request type that you're sending. Request timeout is self-explanatory. 409 is sometimes meaningful. This would be like, maybe if you were like making a game for your web application and someone sends a request to score points in a game that has already ended, like I'm sure your API allows that, like the database allows that, you're just incrementing a number, but it doesn't make sense in the context of your application logic. So in that case, you might send the user a 409 response to indicate that what they've asked you to do doesn't make sense given the logic of your application. Unsupported media type can be useful if you're taking image uploads and you only take JPEGs and the user uploads a GIF. You can tell them that they're almost correct. They just need to use a different image format. Range not satisfiable is useful if you have like a paginated API. If they request like page 7 of results, but there's only 5 pages of results, you can give them this response. Oh, and then 429 for rate limiting. So if you just can't handle too much load and you need to limit how quickly an individual user is sending requests, then you can send a 429 response to let them know that the request they sent was actually correct and valid. They just have to send it later. So yeah, just to reiterate, so yeah, I've like for work in the past, I had to use an API that only sent 500 responses for anything that was wrong. So like if we misspelled like a parameter or we request a page that's out of the page range, we do anything that the API is not like 100% prepared to handle, and it would send a 500 response. And this was even like an API from like a really big, like well-known company, well-known for their technology that we would expect better from, but it was just the worst API I'd ever worked with. And this is honestly like something that I still remember to this day as reasons why I'm glad I don't work there anymore. Because like that one dang API that just only returned 500 error messages. So whenever we got a bad response, like we had no idea what went wrong. And even like a lot of times there would just be like a temporary hiccup. Like, you know, sometimes requests randomly fail, like the internet just doesn't work for 10 seconds for unexpected reasons. And we would still get like a 500 error instead of like a timeout or anything. So just the fact that we had no idea what went wrong and we're just constantly guessing and checking, throwing spaghetti against the wall made it extremely frustrating to deal with that API. All right. So let's look back up here. These URLs, actually, I'm going to just write a new set of URLs down here. But I want to think a little bit about how we write our URLs. We've been talking mostly about the request method and other aspects of the API, but let's talk about the actual URL. So the most important principle here is that URLs should have nouns, not verbs. This like one specific line has been like burned into my brain because of like one specific interviewer that just kept repeating it and was just like really scolding me. Like he asked me like, how would you design an API that does whatever? And I'm like, what about this URL? And he's like, that's dumb. You should have nouns, not verbs in your URLs. Nouns, not verbs. And I'm like, okay, geez. But so I Googled it and I was like, rest, nouns, not verbs. And apparently like that guy was not the first person to use that phrase. Nouns are good, verbs are bad. So this is like a concept in RESTful API design. So for example, let's say we wanted to create a user. We would post to /API, and then probably we should version our API. So this is going to be, we'll imagine this is version 2 of our API, and then users. And then there's going to be a body with that post request containing like email, jeff@amazon.com, and the password is dragons. So this here is just kind of like the root URL of the API. Then the interesting part is over here, we are posting to users. So this basically means create a new user in the users collection, create a new record in the users collection. So note that we don't have to specify create user or anything like that. There's no verb in the URL because the HTTP method is sufficient to say what we want to do. The URL only has to specify what we're doing that action to. All right, so if we want to just retrieve information about a user, we would get, and then probably put the user's ID as a parameter in the URL. API v2 users 456. So this would get us information about this user. Similarly, so in this example here, we are querying a specific user. And in this example, we are querying the users collection itself, which should return to us all of the users, except that we're adding a parameter here, a filter, only get me the users where their city is Chicago. And then if we want to update a user, we would send a put request. So users/345 is saying who we want to update or what we want to update. And then just this put 3 letters, that should be sufficient to specify what we want to do to them. We're doing some kind of an idempotent update. And so of course we would include a body here, probably. I don't know. And then lastly, we want to delete a user. Just the method name itself is sufficient to say what we're trying to do. So the URL only needs to specify who we are deleting. So we're going to put that ID right in the URL here. So generally speaking, this is what you should try to do. Have the HTTP verb describe what you want to do, and then the URL describe what you're doing it to. However, there can be exceptions to this rule. So sometimes you might need to perform more than 4 different actions on the same resource, or maybe none of the existing HTTP methods accurately describe the action that you want to perform. So in REST, you can have a concept of an action as a nested resource, or like a resource inside of a resource. So kind of an example of that would be if you want to change a user's password, you might have a route like post/API/v2/users/345. So note that this URL already exists. Actually, it doesn't. Okay, but nonetheless. So like setting a user's password it's kind of a complex operation because, there's all the password hashing that goes on. It's more than just a simple like setting a field in a database. So, given that we don't want this to be like retried automatically, it's kind of a sensitive operation. I'm going to use a post request for this, but we don't just say post API v2 users 345 because that's not sufficiently specific to describe what we're trying to do. So since this is kind of like a specific action that we're performing on a user, that's not just a generic like update the user or like create a user or whatever, I'm going to put an action name in the URL itself. And so this is kind of an exception from the normal rules of REST, but it is perfectly RESTful. So I just want to show you real quick. So I know we haven't used Django REST framework very much. And so this code snippet is not going to be too super meaningful to you. But I just want to let you know that Django REST framework also has this concept of actions built into it. So like if you want, you can use Django REST framework and it can take one of your models and it'll automatically build a set of get, post, put, and delete routes for that model that let you create, update, delete, and retrieve records from that model. But it also lets you just define custom other actions. So that's really great because Django REST framework isn't like perfectly rigid. It doesn't just do one thing and make your API perfectly RESTful. You can add in these exceptions. You can add in these actions that do whatever you want. So this example is actually the same thing that I just showed you. This is using Django REST framework to define an action. So we use this decorator called @action called set password. So this would create another URL for your user's model that ends with set password. So you don't need to do this for your projects in this cohort. It might be useful to you, not a requirement. I'm just letting you know that this concept of actions is not something that I made up, but this is like a named idea in REST, and that other RESTful frameworks, if they're trying to help you build a RESTful API, they will have some accommodation for actions. So I know that section was a little bit abstract. Do we have any questions, any more questions before we move on to the next section? No questions. Okay. So we've only got like 2 or 3 more sections in today's lecture. So I think this is probably a good time for a break. It's 10:40 right now. Why don't we come back at 10:50 and then we'll talk about caching in REST APIs. All right, see you soon, folks. All right, so we just finished talking about using nouns and not verbs in our URL. Next thing I want to talk about is caching. Another important thing that a RESTful API should do. Do you still put the E in it when it's in gerund? How people spell this?
I don't
No,
think so.
no E. Wait, actually. I think that might also be an acceptable alternate spelling. Anyways, I'm not going to think too hard about this. So when a user sends a request to your RESTful API and you send them a response, a RESTful API should use headers, they're called cache control headers, to instruct the client on what to cache and for how long. So imagine, for example, if a client requests weather data from an API, the API should instruct them not to cache the data at all, since it's likely going to be different the next time they check the weather. On the flip side, if a client requests data about a historical event, the API should instruct them to cache that data indefinitely, since it's unlikely it'll ever change in the future. So there are also going to be some situations that'll be in the middle of those two examples. And so you might have to decide, how often is this resource going to change? Maybe the client should cache it for hours or days or weeks, whatever makes sense in your situation. So let's see. Where is that? Okay, here we go. This is what I'm looking for. So Django, so this is just a header for the caching behavior, but it's such a common header that you need to set that Django includes a decorator that will help you set it in a more convenient manner. So we use this decorators.cache, import cache control, and then you can decorate any route with cache control and then max age. And then that will instruct the clients to cache the response for only this amount of time. So I'm going to see if I can open up DevTools and see a cache control response. Yeah, so here, me just requesting this page, docs.djangoproject.com, the documentation about caching. This page itself, this HTML document is cached. So where'd it go? So yeah, my browser is being instructed to cache this document for, I think this is 300 seconds. So that's like several minutes. So it's not super long, but that basically guarantees that like, if this page is ever updated, the docs get changed, I'll be able to view that new version, not immediately, but like within the hour probably. But if there are like 100 people that are just constantly sending requests to this website trying to get the documentation, and they're just like refreshing the page over and over, like it's not gonna send, how do I put this? It's not going to force the server to like recreate the response every time. Like imagine there's a Django template that creates this page. Django wouldn't have to re-render the template every time it receives the request. It would just be able to tell the client like, hey, you've cached this response and it's not expired yet. So just use the version you've got locally instead of forcing me to recreate the same thing that you've already got. So by intelligently setting the max age, you can get the client to cache the responses, and that's just another way to reduce load on your server.
So when you have like Django and React together, would you like just put that on your index page that renders the index.html? Your index view, I mean?
I feel like in theory, that would be a smart thing to do, but that would probably be frustrating during development because you wouldn't want your browser to cache anything because every time you reload the page, you're probably looking at a different version of it because you're editing it because you're a developer. So maybe when you go to production mode, you would set cache control for the homepage. Honestly, this is like a level of optimization that I've never really thought about. Like I've just always had more urgent problems to solve, but I suppose it would be a nice thing to do. Sorry, I couldn't give you a really concrete answer there, but I hope that helps.
No, they answered it. Thanks.
Any other questions about that? All right, so yeah, that's about all I have to say about caching. It's not like an outrageously complicated concept, but it is moderately important that you set important, like meaningful cache values. Like especially for a public API, so that your server doesn't get overloaded with like tons of identical requests. All right. So there's one more RESTful principle that I want to talk about today. And now throughout this lecture, as I've been kind of going down this list, we've been getting to less and less important principles of REST. Really the statelessness and using the correct methods. These are probably the most distinguishing features of a RESTful API. If someone asks you, what do you know about REST? These are probably the first two things you should talk about. But, as we go down the list, these things are also important, just a little bit less important. And so at the end of our lecture, what is, in my opinion, the least important aspect of a RESTful API is probably the ugliest acronym you've ever seen, HATES, which stands for Hypermedia as the Engine of Application State. So what this basically means is that hypermedia or hyperlinks, or let's just say links, are what drive the application state. That's how you get from one state to the next. So more specifically, what this principle means, HATES, is that every response from the server should contain links to related actions or resources so that the client can continue exploring the API. So as much as possible, developers should not need to read our documentation to know how to use our API. The responses themselves should serve as documentation. So in my opinion, this is not super useful for REST APIs the way we use them commonly, because like a human isn't going to be reading the responses and looking at the URLs that the response gives you and kind of deciding like, oh, where do I want to go? you've like written your application logic ahead of time, and you've probably read the docs ahead of time. And so you already know what URLs you can request at the time that you like build your client-side code. So I don't think it's especially useful including these links in the API responses. However, many like tools that you might use for building an API can do this for you automatically. So if it's already there automatically, then like why not include it, I guess. I feel like this principle makes more sense with an HTML API, where every resource is represented by an HTML page with anchor tags that link to other resources, and then a user can interactively navigate from one resource to the next, like the web. So in that case, you actually have a human who's like interactively going through your API. So HATUS makes sense to me in that situation. But commonly when I'm using an API and it returns links to me in the response, like I don't usually use them, I guess. But there are some exceptions. So if we go to the Pokemon API. So the Pokemon API implements HATUS in a very like good, consistent, reliable way. And I actually really like it here in this API, just because there are so many different things that you can query for, just between like Pokemon and abilities and the games and types. And they just have a really big API, and I didn't feel like reading all the documentation. But it's pretty convenient that they give you all these URLs here that let you continue following the API. So I don't have to, read all the documentation or know how it works. So now here, we're looking for, what is this, Ditto?
So it's almost like in a HATUS API, if you make one request, there should be enough information in that request to be able to traverse laterally and the not laterally word.
I don't know what the word is, but I know what you're getting at.
Yeah, yeah. So
yeah,
like,
parent
for
resources,
example, the
child
Pokemon.
resources, siblings, related stuff.
Yeah, like for Pokemon, you can search a Pokemon, but then you can also go to it provides a URL to the types list of that Pokemon, and then that URL will include, etc. You can basically navigate from that one search.
Yep.
Okay, I see.
So another good example of this is the GitHub API.
You mentioned that wasn't very helpful. If you said that's not very helpful because humans aren't reading this stuff, you seem to imply that HATUS doesn't seem very necessary because machines are the ones reading and interpreting the APIs. But I thought it always has to start with a human that is, telling the machine what to do with the API and how to navigate it. So I'm kind of confused by
Like
that.
a human who is like writing Axios calls to communicate with some API, they probably have documentation up in front of them for how the API works. And so they're going to be able to construct these URLs just knowing that like, okay, here's the base URL. And I want to get a Pokemon form, and like, okay, I just request a Pokemon with the ID of 132. And so you just do a little bit of variable interpolation. Like you don't need to be given the whole link by itself because your code can construct it easily. But a user, maybe they don't have the awareness to notice that there's a pattern in the API, and they're not able to figure out what the links would be. And even if they can, they wouldn't want to type it out themselves. So it's nice that you can provide a user with links that they can click through.
Okay, so it's convenience and stupid proof.
I think so, yeah.
Gotcha.
Yeah, so saying the GitHub API. So this is my open source project, but instead of just going to the regular repo page, I went to api.github.com. And so I get this JSON response. And it tells you, a lot of basic information about the repo. It's not private. It's got this ID, tells you a little bit about the owner. It's our Sirota, that's me. But there's also a whole bunch of links that show you everything else you can do to interact with this repo. So if you want to see the followers that I have following this repo, here's the link for that. If you want to look at the stars, this is that. It's kind of weird that it's with placeholders here, owner/repo, instead of just this repo itself. If you want to see all the people who forked it, there's this URL over here. So yeah, all the different URLs of different ways you can interact with a repo, well, many of them at least, are included here. So Pokemon and GitHub are probably the two best APIs I've seen in terms of implementing HATIS. So yeah, all these other considerations for REST APIs that I've mentioned, I think that they're very important. I get frustrated if I am using an API that doesn't have meaningful response codes. I get frustrated with an API that does not, write their URLs and does not use the method types according to the conventions I expect. If it's expecting state when I think everything is stateless, that's going to define my expectations. I guess I don't usually think too hard about caching, but you should abide by this as well. And then HATIS is whatever. So yeah, this is generally what I expect a RESTful API to do. But to reiterate, I think I've mentioned this before, but when should you use this or not use this? So I'm going to give you a very vague and generic answer, but use REST to make resources on your server available to clients. So a lot of the things that you're going to do with your server, you could consider making resources available to clients. So a RESTful API might be a good way to design those URLs. But note that not all HTTP verbs make sense for every resource. Only use the ones you need. So like, for example, I think it's kind of funny that if you get some kind of like automated tool, like, Django REST framework for just generating API routes, like by default, it's going to create, get, post, put, and delete URLs for all of your resources. But like in most common web applications, they're not just accepting delete requests for like every resource. Like you can't just delete random stuff on demand. Like there might be some like specific logic, some specific application flow for deleting a user or for like deactivating a user or deactivating some other record. But rarely do like actual web applications just let users like delete random records. So the fact that it's like the default behavior for a lot of these REST frameworks is to just create delete routes for every model, I think is kind of funny. But yeah, so you don't need to use every method for every resource. Just do what makes sense for your API. What questions do we have here? Oh my gosh. Someone made this joke last class too. You guys are too funny. All right, so let's take a few more questions, and then I have another little thought experiment for you. Gonna ask a question about a RESTful crisis, and I want to see what you alls would do in that situation. What questions do we have? Go on, don't all pretend like you understood this. All right, well, let's move forward then. So I've got an example of an API design problem. This happened to a real company. This happened to Dropbox. This was actually kind of a while ago. I've been using this example for a while. Yeah, I think this happened in like 2011 or 2012 or something. So Dropbox used to have a route called /delta. And let's see, it was specifically get /delta. It was idempotent. And what it did was it would return information about changes. So, Dropbox is all about managing different versions of your files, collaborating with different users on different machines. And so they had this route in their API that you could query, and it would tell you what changes have happened to your different files, across different machines and whatever. And it was a very complex route, returned a lot of data. And so there are a lot of ways that you could query it, lots of different filter parameters and stuff. But that was kind of a problem because it was using a GET request. And GET requests cannot have bodies. They can only have a query string. So remember, there is a limit to how long the URL can be. So there is actually a practical limit on how many parameters you can stuff into the query string. It's not an issue that most of us will ever deal with, but apparently this /delta route just had so many parameters and they couldn't fit them all in the URL. So there were two options that Dropbox was considering about how to change their API to accommodate the fact that they had too many parameters to put them in the URL, and GET requests cannot have bodies. So proposal 1 is use post. So post requests, they can have bodies. So we could put the body of the query, all like the filters, all the different query parameters, we could put that in the body of the post request. And that is much less limited than the query string. Unfortunately, the downside to this is that post is defined as being not idempotent. But I've already told you that what this route actually does is it just returns data and it doesn't change anything on the server. So it semantically doesn't make sense to be using post for this request. So solution 2 is use report. It's another HTTP verb. So the report HTTP verb is defined as safe and idempotent, or actually not sure if it is safe, but it is idempotent. And also, actually, I'm pretty sure it is. But also, report requests may contain a body. So it kind of seems like this is the perfect compromise, that it has the right technological aspect to it. A report request can contain a body. And we need to have a request body to include all of our query parameters. But it also has the correct semantics, because a report request is defined as being safe and idempotent. It is, understood according to the definition of HTTP. It is understood to have no impact on the server state. And that's what this route does. It has no impact on the server state. So let me ask you all as a class, which of these two method types do you think would be more appropriate for this request?
Report.
Okay. Why do we think
Appropriate
that?
or useful?
What's the difference?
Well, it seems like a report is appropriate, but it may not be as useful if people don't understand it or use it.
I mean, in the context of a business that is trying to make money, what do you think is best?
I guess I didn't really
Post.
consider that their
Post.
API design would affect their money making.
Everything affects the money making. It needs to be easy to work with so that the developers can write code against that API, spending minimal time reading the documentation and with minimal chance of bugs. If you make like really poor API design decisions, people are going to have a hard time working with it and just waste a lot of time in building applications with it.
It seems like post would be the easier answer on the developer side. And the only real downside is on the user end, is they get the, resubmit behavior, and the browser will behave as if it's not idempotent. But that's not terrible.
Yeah, so that's right. So using the report method would be more restful. In a sense, this is more like technically correct to use report because it's got the right technology and the right semantics. But the problem with report is that report is very obscure. Most developers have never heard of this before. So there's maybe like a dozen or so, couple dozen HTTP methods. Let's see if we can see them all.
So I guess the moral is
Definitely
companies
more than
don't have
that.
time for you to learn something new. To do it right. They typically don't want right, they want fast.
They want intelligible.
Yeah, they want good enough.
Well, I mean, to that point,
I don't-
like, wouldn't the, kind of the, what's the word I'm looking for? Intuitive answer be get? And if get didn't work, wouldn't you have to, or I mean, I guess you could just start going through, but like, wouldn't you end up needing to read anyways? And the only difference between post and report is literally the word that you're using for your request.
I mean, the semantics are different. They're understood to mean different things, but yeah, they're technically the same.
So I mean, like, if I were to try and send a request to the API, I'd be like, oh, I'm just getting information. I'm going to try get. And then I'd be like, oh, that didn't work. And then I'd have to be like, okay, well, let me go read what I'm supposed to do. I mean, that wouldn't changing it from get to post kind of create the same problem as changing it from get to report.
So, I mean, probably no one's going to be like thinking that they should send a GET request. Like they would read the documentation. Like if they knew that there was a route / delta, they would know it accepts whatever method type it accepts. Because like in the documentation, they would put these two things together, like the method type and the URL. So if you knew the URL exists, you would probably know the right method type to send. But the issue is, upon reading that in the documentation, does that surprise you? Or is the developer thinking like, oh yeah, that's basically how I expected this to work? So if the documentation says like, yeah, just send a report request to this URL, that's probably going to surprise the developer. They're going to be like, I sent a what request? Like most developers have never heard of it. You know, if you look at a list of most common HTTP methods, this is probably not in that list.
Is there a concern that the report method wouldn't be recognized by browsers?
So the browser would recognize it, but perhaps your API client wouldn't. So like Axios, you know, has these methods built into it. Like Axios.get, Axios.post. It has a few of these like helper methods for common method types. I'm pretty sure there is no Axios.report. You can.
So if a developer was using the like Axios, for instance, then they wouldn't be able to just follow the, just replace it with report.
I mean, they would still be able to do it. You can be like, so there's still this syntax. So you can just write in whatever you want and Axios will do its best and send that type of method. But there isn't like a little convenient shortcut for it. So if you're building an API that depends on report requests, the user might have to like change their syntax, change their style of code, or might even have to use a different tool for sending that report request. It's possible that some tools that they use for sending API requests only support maybe like a dozen options and they don't include report. So even though this is, you know, RESTful according to the standards and definitions or whatever, this would definitely be very disruptive to developers. So what Dropbox ended up doing is using solution one, just using post. And of course, this is not very RESTful, but developers can get over it. Like they read the documentation and it might just have a quick note that calls out like, hey, this request is safe and idempotent, but it uses post to have a body. And, you know, with that brief explanation, they'll be like, okay, yeah, I guess that makes sense, whatever, moving along. And they're not going to think too hard about it because they know they can send post requests and it's not going to be a big deal. So I guess the point that I'm trying to make here is like, don't be dogmatic in designing your API. Don't follow all these RESTful principles just because they are RESTful principles and you are a RESTful API designer. Like, I really want you to think critically about who this is helping. Like, following any of these individual principles should either like make your API perform better technically, like with the caching behavior, or should make your API easier to understand for other developers. If in your specific situation, following some RESTful principle doesn't do either of those things, like here using report does not really make the API easier to understand, even amongst developers who claim that they understand REST. So I wouldn't use the report verb in that case because it's not really meeting your goals.
It sounds like the limitations of get and the lack of a report method are kind of one of those lack of foresight problems, kind of like IPv4 and IPv6. You know what I mean?
Yeah, I think the designers of these standards and styles never imagined that people would have so much data to put into a GET request.
Hmm.
So, I mean, this is not a common problem. Like, I've only heard of this issue happening in this one case with Dropbox.
Right. And Dropbox is like housing so much stuff, so it makes sense.
Yeah. All right, so yeah, that is all the content I have for you today. You do actually have an exercise for tonight about RESTful API design. Yeah, it's really just kind of a thought experiment, not asking you to submit any code, and just kind of think about what would be good URLs and methods for, you know, hypothetical businesses or applications. But all of the homework for tonight is optional because, you know, we're in the middle of personal projects. In particular, the second assignment about the to-do list, like, don't even look at that one. This lecture got moved around. It was somewhere earlier in the curriculum previously. So given now that you're actually just building full stack applications, it wouldn't make sense for you to do this homework at this point. We might have actually already asked you to do this previously, and I think I just didn't remove it as an exercise from this day. Anyways, so point is, do the RESTful API design assignment if you feel like it. Otherwise, just focus on your personal projects tonight. Justin?
I don't mean to make a hand gesture, but whatever. This little whatever. Anyway, I mean, if we have a few minutes, would it be useful or practical to just look at one of those and go through it together with you? You know what I mean?
The like potential like example APIs you're saying?
Yeah, like one of those assignments. I mean, you kind of just said that they're optional. We can go through it if we want, but
Yeah, why not?
what if we just take 30 minutes to just kind of look at it before lunch?
Yeah, where did I put the curriculum?
Might help drive some of these things home.
All right, so 3 businesses we will be designing RESTful APIs for: a job board like Indeed, social network like Facebook, and a library with books, movies, accounts, finds, and available computers. We will have to design an API for each of these, thinking about the resources that each of these apps might need and what actions would we want to take on these resources, and then what URL and HTTP request method should be used to perform these actions. We'll have to think about if those actions are idempotent and what kind of status codes should we return. Are the results cacheable? So which one of these businesses do we want to approach first?
Let's just go top to bottom.
All right. So let's start with a job board like Indeed. So we're going to have at a minimum job posts, companies, resumes, and applications. So what are some common actions that we might need to do in this application?
Companies, job posts, resumes, and applications. Yeah, get post
of jobs.
Heard a few things at once there.
Just a general get for getting job posts, filtering by companies.
So get jobs, maybe a company. Okay, so what else are we gonna do with jobs? Well, actually, let's think first, what status code would this return when it's, successful? And how long should we cache this for? I think I saw 200 in the chat. Y'all can just shout it out though.
At 200 works. Indefinite cache.
Indefinite.
Yeah, wouldn't we just cache it until they delete it?
Depends on how big the result is, right? I mean,
I guess a job post does represent like one specific opportunity. So I guess you wouldn't really need to cache it. You would expect that just different job posts would be available in the future. So I guess the caching behavior maybe doesn't matter as much for a job post.
well, this would be a list of jobs for that company. So unless they click into a job post, you might cache that maybe.
Oh, yeah. Yeah, that's a good point. Okay, so we're not getting a specific job, but we're getting jobs itself. So in that case, it would probably be problematic to cache it indefinitely because you might get a different list of jobs every time you request it based on what's been posted recently.
Right. So no cache.
Let's say short cache,
Fair enough.
maybe 1 day cache.
So would it prioritize your cached information rather than pulling information if it were indeed updated?
Yeah. So
That's
that's
sad.
like a bug that you can encounter sometimes in a web application, that there is actually newer data than what you're looking at. But because the old data has not expired yet in the cache, you're still going to use that cache version until it expires.
But the value of putting a cache in is to prevent too many calls to your database for
Right.
information. Okay. But if the user is relying on seeing jobs posted or removed in real time, then obviously you wouldn't want to cache that.
Yeah.
But that'd
So
be
I
really
think,
heavy on your server.
yeah, I think a good example is like the Reddit front page, where you can see all the top stories, and the comments and upvotes or whatever. So if when you load the Reddit front page, if the top story, it doesn't show you exactly how many comments it has, like if it tells you that the top story has 10,000 comments, but it actually has 10,006 comments, that really doesn't matter. Like it's, a 5-digit number of comments that gives you a rough idea of how many people commented on it. You're not going to read them all. The difference between 10,000, 10,006 doesn't matter. But if every time someone requested the Reddit front page, it had to do a complex database query and like join a bunch of tables to count how many comments were added to a page, like Reddit would crash in a minute. It just can't handle that kind of traffic from that many users and like that many database queries. So Reddit has, correctly made the trade-off that they're willing to show you slightly outdated data so that they don't overload their servers as easily.
Makes sense.
Okay, so what else do we have to do with jobs?
Got to post them.
Of course, we got to post jobs. So what other information do we need with the job? It's probably like a body for this request. Imagine it's got like,
yeah, have all sorts of shit. Created, title, detail, description, etc., etc.
Job ID.
So for posting, we probably wouldn't specify the job ID because the database would create the job ID when we create the record. Which means that, there's a risk that if we send multiple identical requests, it'll create multiple identical jobs.
So we'd also have a put for updating the same job, or for updating a given job. and then delete for all that. So pretty much all the functionalities for jobs themselves.
So that would have to have an ID in it. And then we can specify just the parts that we're changing. And then delete, although delete requests do not have bodies. And of course, for the post, put, and delete requests, we're not going to cache anything at all, because it's kind of expected that like this has an action on demand when the user sends the request. And so the response, should be unique in response to what the user did. So it doesn't really make sense to cache the response for post, put, or delete requests that are supposed to have an impact on the server. But we should be sending status codes. So what would be good status codes, assuming these things work successfully?
Work successfully?
201.
Yeah, so probably a 201 when we post a new job.
202 for created or for accepted.
What's 202?
Accepted.
I don't think I've seen this
But
one
not yet
before.
acted upon. Okay, maybe not. It's non-committal.
Speak 200 again.
200's fine, if you can't
Yeah.
think of anything more specific. For a delete request,
200. Yeah.
200's fine. I might even do no content potentially as the response. Because all the user needs to know is that the thing they tried to delete was successfully deleted. I don't have to give them any other content, but 200 is also perfectly clear. All right, so what else does our job board need? Posts, companies, resumes, applications.
So posts would have, or job posts would have, well, I guess users would have resumes.
So we have kind of some design decisions here. If you want, you can consider these to be like nested resources. Or I guess
They wouldn't be
users
publicly
aren't
available,
actually
would they?
mentioned here.
It wouldn't be publicly available. You wouldn't just be able to query it for somebody's resume. But I guess.
Yeah, there would be some kind of access control on things. Like, maybe only employers can query for people's resumes, and only if it's a person who applied for a job that you posted or something like that.
I see.
Or maybe the resume would belong to a specific job post.
Right.
Because, a user probably uploads multiple copies of their resume. Like every time you apply for a job, you might use a slightly different version of it.
Or a job post would have a list of resumes submitted to it.
Yeah.
Yeah. So already we've kind of expressed a restful approach by determining what methods would need to be used and evaluating what kind of HTTP responses we would want to be able to throw with that, or we should, and whether or not we should cache the data. And those are namely, and how we wrote the URL itself.
Yeah, making sure that the URL just specifies what resource we are acting upon, either the entire jobs collection or a single individual job resource. And then the request method describes what we want to do to it.
So it seems like just right here, we already expressed all of most of the elements of implementing a RESTful design or approaching it in a RESTful way.
Yeah, all the common elements, I'd say. But there might be something that we need to do with jobs that doesn't quite fit into this scheme. Like, is there a fifth thing that we might need to do with jobs aside from just getting them, creating them, updating them, and deleting them? Maybe not. I'm just thinking out loud here.
Maybe to update, sometimes they update the description.
Well, that would just be with a put request. So send a put to job/the job ID, and then in the body specify what we want to change about it. And then based on this URL scheme here, I would expect it to change that resource to make it look like this.
I guess that begs the question, and like you mentioned, I think really the only time I've heard anything beyond get, post, put, and delete is your mention of report, and even that was kind of I mean, it's not even utilized anymore. And the only other request methods I see on the MDN web docs are, head, connect, options, trace, and patch, which we've never spoken about, which
Yeah, you don't necessarily need to use a different request type,
I see.
but we might need like an action or something. So
Okay.
I think the job board might be a little bit too straightforward even. But if we think about the library, common actions you might need to do in the library would be like checking out a book or returning a book. And so let's see here. So that might be hard to describe with just get, post, put, delete, because that's
Yeah.
just kind of changing the relationships between existing records. We're not like adding a new like book or anything to the database. We're adding an association between a book and a user, but that's not like a resource in our RESTful API. That's just a table in our database. So let's think about the library actually for a few minutes. I'm going to change gears here a little bit.
So it seems like from an inventory perspective, we would do a lot of the same things we just did. But from a user perspective, the difference between putting user/books/checkout versus return might be two different puts kind of thing.
Sorry, can you repeat that?
Oh, I was just kind of spitballing. In terms of the inventory, it'd be a lot of the same stuff, but when it comes to a user interacting with their profile in the books that are checked out by them, a put request might look different depending on whether they're checking out a book or returning a book. Or perhaps it would be more of a delete for a return. I'm trying to think of how we might have multiples or a different circumstance.
Maybe a post for a return if it's just updating, or put if it's just updating like the user's account or the number of books in our inventory.
I think put would be appropriate. So probably so maybe something like this is what I would do for returning a book. So it's idempotent. If you try to return a book that you've already returned, nothing happens because the library got it the first time you did that.
but checking out a book would be post because you may want to check out. Technically, you could check out the same, well, a book more than once. Maybe not a specific.
Let's say
book,
each
but if you
copy
got
is unique in the
multiple of a book-
database.
Yeah. Right.
So I would probably
Well,
still
okay.
use put there.
Still put.
But yeah, so the important thing to remember here is that if this was just put/users/345, we would interpret this as updating this user. Or if it was just put/books/1098, we would interpret that as just updating the book. But what we're doing here is not just a simple update to one model, but we're changing the relationship between two models. We're changing the association between this user and what books they have checked out currently. So it's hard to think about that kind of an action with just the simple get, post, put, delete, like the 4 main CRUD actions. So it makes sense to me to think of this as an action in REST. So nested underneath the users collection, we have this action to return book. It is a thing that a user can do. We need to specify extra information about which book they're returning. And then should ideally return like a 200 status code or something if it worked correctly. Yeah, I guess the failure status codes are a little more interesting. But yeah, so this would be just like a 5th thing that we could do on a user or on a book. It's not even really clear to me if this is more of like a book related action or a user related action. It's a little bit subjective in how you define your APIs.
I think that's fair. We just practiced it a little bit, and it kind of makes sense how to categorize RESTful approach.
Yeah.
In terms of how you write your URLs, making them make intuitive sense, determining whether or not caching is appropriate, managing your errors. Those are the most common methods of RESTful approach.
Yeah, so I don't know. This is just kind of generally my thought process, I'd say, when I'm like writing my URLs. It's not outrageously complicated, but a lot of developers just don't think of this at all and just kind of cowboy code whatever routes they feel like. And it can be kind of hard to follow after the fact.
Cool. Thanks for going through that.
Yep.
It helps.
I hope that was, hope that was useful. Glad. Any other questions? Cowboy code. I remember my one of my early programming mentors in a boot camp, actually, he was asked, this was like the instructor at the boot camp I went to, he was asked if he prefers object-oriented coding or functional coding, and his response was cowboy coding. He just does whatever he needs to get the app to work. So I think that's kind of a funny mindset.
Did he get the job?
I mean, he was working currently as my instructor at that boot camp, so yeah, he had gotten the job. He didn't stick around though for the second cohort. I think teaching wasn't really for him.
Yeah, cowboys can't settle down.
I guess so. So yeah, it's just 10 minutes to lunch. I think we can get out of here a little bit early, unless we want to continue going through all these examples here. But I feel like people are starting to get the idea, starting to understand the thought process. Do people have any more questions before we break for lunch today? No more questions? All right, cool. So thanks everybody. That concludes my lecture for today on RESTful API design. I hope you found that interesting and useful. And And yeah. See, what do we have going on this afternoon? Nothing. All right, cool. So we'll see you tomorrow, folks, or see you for stand down tonight at 4:30.
4:30. Hi.
4:30. Okay, I'll catch you later, folks. See ya.
Take care.